Hello, everyone, and welcome to today's free public webinar with TPC entitled Understanding Generator Ratings and Safety Labeling. My name is Ryan Smith, and I am joined by our presenter today, Bob Kluke, one of our esteemed TPC instructors and an expert in the electrician field, having worked on many generator systems himself. Looking forward to hearing a little bit during this hour-long free webinar event, all about generators and their safety labels and ratings. So before we get started, I'd like to just let everyone know who's here a little bit more about today's session. First and foremost, this webinar is being recorded, and the recording of this session will be made available on our website at live.tpctraining.com within 2 business days of today's event. So be on the lookout for that, and you'll also get an email with that link. Also, at that time, you'll see a PDF of the slides available for you as well for you to look back and peruse. And then finally, you should be able to interact with us during this session. So let's see. Yeah, so you're going to see a Q&A button at the bottom of your screen, which is a way for you to ask questions to us called Q&A. Now, be careful about using the chat. So we're really not going to monitor the chat for the session. So really try to use that Q&A button for any specific questions you have for Bob, and we'll be able to answer them as many as possible by the end of the session. And then finally, we got a couple of questions from folks wondering if they're going to get official certificates of completion for this course. This is not, an official course necessarily, but an informational event, a free public event. So we're not really offering certificates for this event. However, highly encourage you to really take one of our official 2-day emergency generator power courses, which do offer you a full certificate of completion for those courses. So before we get it over to Bob, we would love to learn a little bit more about who's here. So we're going to run a little bit of a poll with just 3 basic questions for you about some of your experiences with generators leading into this webinar. So I'm going to go ahead and launch the poll to you all. And so you should right about now see a window popping up on your screen. And you can go ahead and click any answer that applies to you in your experience and then hit submit at the bottom to answer these poll questions with your experience. The first question is, how is your generator serviced for maintenance? Do you service your generator in-house, using outside contractors, a mixture of both, or you're not really sure, which is okay? Question number 2, what type of generator do you have at your facility? And you can check all that apply. Do you have stationary, mobile, portable generators, or not sure which one you have based on those? And then finally, what fuel powers the prime mover of your generator? What fuel fuels your generator? Is it diesel, natural gas, gasoline powered generator, other, or you're not quite sure? So we're getting some great responses coming in to the poll. So I will give you all just a few more moments to provide your answers here. All right, good. So I think we got a evening out of the answers provided. So I'll go ahead and end the poll. And then I will share the results with everyone here on what our answers were. So for question number 1, we're seeing that how is your generator service for maintenance? Most of you have both kind of a mixture of in-house and outside contractors. However, for those of you doing one or the other, by far outside contractors are being used, so 31%. And that really speaks to the value of getting your own generator training. So maybe you can start doing more of these tasks for maintenance in-house. Number 2, what type of generator is at your facility? Far and away, the most popular answer here, 88% of you say that stationary generators are the ones you have at your facility, followed by 35% of you have portable generators. And then again, far and away, the fuel that's powering our generators, 76% of you say diesel is the fuel, followed distantly in 38% of you with natural gas and then gasoline. So that helps us know kind of a little bit about what types of generators folks are working with and a little bit about their experience leading up to it. So without further ado, you can all feel free to close your polling window, and I will go ahead and stop sharing the results so it happens automatically. There we go. And now you're all feel free to direct your attention. Make sure you see a full screen that says our title, Understanding Generator Ratings and Safety Labeling. And without further ado, I'll give it over to Bob. Thank you so much for being here, Bob.
Thank you, Ryan, for that, and welcome everybody. I'm glad you could attend this session. And we're going to be looking through a variety of different nameplates and different conditions about generators. And like Ryan said, the Q&A is the place to really ask all your questions, which we will address at the end of the presentation. So we're going to start with the National Electrical Code. Of course, that is an installation document, and Article 445 is the article that deals with the installation of generators. And we can see that right straight from the manufacturer has to provide us with a nameplate giving us who made the generator, what the frequency is, the number of phases, AC or DC, the wattage of the generator, the power factor has to be on there. So also we can see what ambient temperature the generator is going to be installed in and the rated temperature rise. And when they talk about temperature rise, that is how much that the internal stator windings can increase in temperature over the ambient. So um, we're gonna take a look at all those different factors coming up here. Now, this information is regardless of size. It does not matter how large the generator is, how small the generator is. All this information would have to be on any size generator. But now we're going to take a look at some generators that are larger. These are generators are going to be rated above 15 kW. So, of course, most of your generators, when I heard they were stationary, are definitely above 15 kW. So let's take a look at what has to be on those nameplates. And immediately we come up with some large words, right? Subtransient, transient, synchronous, zero sequence, reactances. And the biggest thing that we should know about this helps us determine the short circuit current that the generator can provide. And so this is very important when we are going to install our equipment. We've got to make sure that the short circuit current ratings of switch gear, transfer switches are all going to be above the fault current capability of the generator, along with interrupting ratings of overcurrent devices. So this information is very important that they put on the nameplate. And take a look at now of course, the power rating. So we are going to know how many megawatts it is, or kilowatts, or whatever the generator is. And then the insulation. So they're always going to give us a couple different choices here. It is either going to be an insulation of H or F. And I can tell you that H is the higher of the two ratings. So if you have a generator that is continuous duty, it would definitely be an H insulation, but we'll see some of these on the nameplates that we're going to see. Also, we have to know if it does have overcurrent protection on it and overload protection. So they're going to indicate to us if there is some type of protective relays here, circuit breakers or fuses. And for inverter-based generators, which are generators that are going to first get their power from a DC power source and then invert it to AC, we do have to know a little bit about that maximum short circuit current rating in lieu of what we saw up in number one, which was straight AC the whole way. And just a picture of a small inverter rated generator. So let's take a look at a nameplate here for a second. And so first, a couple things I want to mention over here on the engine side. We can see that the model and the type, four cylinder. But let's take a look at the speed, because the minute that we see 1800 RPM, we know that this is a 4-pole generator, because that 4-pole generator will actually give us our rated frequency, which has to be 60 hertz. So important to understand the speed, and they're not all 4-poles. Some of the smaller portable generators would be 2-pole generators, and their RPM would be 3,600 RPM. So we always want to pay attention to that a little bit. But I am going to concentrate on the other side of this information here, the AC generator side. So we're always going to have a model number. And notice that this says star with neutral. And so the manufacturers do have to give us an indication if the system is separately derived or not. And so when we see that, then we do know that it is going to be separately derived. And I'm going to talk about that a little bit more in detail coming up. This generator, by the way, is a unique generator. It can either be three phase or it can be single phase. So kind of unique. This has a zigzag connection, and I'm going to show you a picture in a few slides here of the handle of how we change from three phase to single phase and what the voltages would be when we do make that switch. 60 hertz, whether we're in single or three phase, right? And then the output, they are telling us the apparent power, which is 45 kVA, and then the true power, which is 36 kW. So, of course, that is for three phase, right? And we have to understand that the apparent power is the total power that the generator is going to be able to produce. But 20% of that is going to be used for charging coils and capacitors. So that's going to be the reactive power that the generator is going to produce. And then the 36 kW would be the resistive power. And so we can take a look at how much more three phase is than single phase, and that's for sure. How they derive that is they just take the numbers over here for three phase, divide that by the square root of 3, or 1.732, and you would see what you would get for power for a single phase. The voltage, so when we're on three phase, we can either have 240 or 480. We go to single phase, we pretty much got a 240, 120 volt system. And when we show you the zigzag connection, you'll see exactly on the handle what's going to happen when we go to 240. Also, we can see the rated current that the generator can produce and the power factor. All generators are going to have a 0.8 power factor. They are going to take the true power and divide it by the apparent power, and that would give us the power factor. In single phase systems, the power factor does stay at 1. This does have Class H insulation on it, so outstanding insulation. And we're going to be looking at a few of these generators, so nameplates. And the last one we look at will encompass everything. Now, if you were really paying attention to the National Electrical Code requirements, this nameplate did not have all of them there. But this is a little bit older nameplate, but that's fine. Some of them are still out there. Back into the National Electrical Code, we do see in dot 11 that there was a change in 2014, and that change is going to require the manufacturer to let us know if that neutral is bonded to the generator frame, because that's going to give us a little bit of an idea on grounding and bonding, if we have a separately derived system or not. So relatively new requirement in the last 7 years for generators. And we can see here how this is going to happen. So this is a portable generator, but you can see that the manufacturer did put right on it that the neutral is bonded to the frame. So depending on our wiring method, depending if we're cord and plug connected or we're going to hardwire this into a piece of equipment, would make a determination on how we are going to ground and bond this generator. And we're definitely going to see the connection of how they are going right to the frame over here. So let's take a look at a separately derived system here a little bit. So here we can see a little schematic diagram. Here is our generator over here. It is a three-phase Y system, and the neutral is connected straight to the common point, but it is also bonded to the frame. So over here, it is coming right straight from that same point and coming right to the frame of the generator. So that does tell us that we do have a separately derived system. And so it is right here. What does that mean for us? That means for us that we do have to get a grounding electrode conductor out at the location of the generator. So no question about that. And one of the easiest ways is we normally would find some building steel, and we would CAD weld to that building steel and get that grounding electrode conductor out to that generator. That is the easiest way. Another point I want to make on a separately derived system is the transfer switch. And so here we can see the neutral is coming down, right? And the neutral is actually transferred. So this is going to be a 4-pole transfer switch. We will be transferring phase A, phase B, phase C, and the neutral. So the definition of a separately derived system is that there is no direct electrical connection from one system to another. So here we have, of course, the utility being over here. And to make sure there is no direct electrical connection from one system to another, we do have to transfer the neutral. And so that is the case. And, most generators that are stationary would definitely be a separately derived system. So on this slide, we can see a couple things. We see a caution sign because they are going to tell us that this generator is going to automatically start, which we should know that in the case. But I do want to zoom in on the nameplate and take a look at this nameplate in detail also just a little bit. And we can see right at the top here that it is UL listed. So that's important. And there are other organizations out there that might also be listing some of these. We got CSA in Canada, TUV over in Europe. So a lot of different places we could get that UL listing from, right? Also, we see our apparent power again, and here is our true power. The power factor they're telling us is 0.8, 60 hertz, just like usual. Now, this one is a little bit unique because we do have 3 different conditions for the generator. It could be for prime power. In other words, this could be the primary power of our facility. We operate this generator pretty much 24 hours a day, 365 days a year, and maybe use another power source for our emergency power, which could be the utility. Who knows? I've run into quite a few installations where the generator is prime power. In this case, though, they put the X by standby. So this one is a standby generator because you can see that's where they put the X. So this generator would come on definitely when there was a power outage. And this is our emergency power for the facility. They didn't check continuous, but it could also be a continuous duty generator if it was built that way. It is 3-phase. It is a 12-wire generator. Notice that it is Y connected, and the windings have been split and connected back up into series so that if we wanted, we could definitely have a different output voltage. Also, it's a 480 volt generator, gives us 753 amps. And then they talk on this one a little bit about the excitation. So this is how we get our magnetic field to produce our sine wave, and letting us know that the excitation needs 53 volts and it's 8 amps. Gives us a little bit of information about the frame of the generator and, of course, the speed. So again, on this one, we know that this is a 4-pole generator, no doubt about that. And then the temperature rise. So the ambient temperature, and it's tough to see here, but that is 40 degrees Celsius. Temperature rise, this is how much that the windings, the stator windings, can increase over the ambient and still have no impact on the insulation value. So that's a really nice high temperature rise on this particular generator. So another nameplate, and we can see that one is pretty good. So here we can see exactly what I wanted to show you before about the Zig Zag switch. So sometimes we'd have generators that can do this. This happens to be a mobile generator. So it's on a trailer, can be moved around. If we go straight 3-phase, that generator would give us 480, 277, no doubt about it. If we go straight single phase, then 240, 120, single phase system. But if we wanted 3-phase at 240 volts, you can see from phase to neutral would be 139. So most of the time here, we'd be running just straight 3-phase delta connected equipment. And it would be straight 3-phase 240 on that one completely. So wanted to give you a little bit of idea on that. And this over here is, again, we'll take a look at this side a little bit. It is a little bit different than the one we saw before. So this one we can see that it does have, again, the choices, but a little bit higher output, and a little bit higher amps, but still zero point 0.8 power factor on the three-phase side, and class F insulation. So this insulation not quite as good as the H, and but still very, very good, probably because this is also a mobile trailer mounted generator. That the reason that they have it, they figure that this is only going to be used temporarily in case a facility does not really have their own stationary generator. So pretty good on this one also. Let's now take a look at, let's see, this is the big baby here that we really want to take a look at real close. So this is going to pretty much have all of our information on it, and I'm going to start at the top. So all of our generators, of course, are going to have a serial number and a unique number from the manufacturer. And then the code. This is a 4-pole generator, and the 2100 is a manufacturing code. When we come down a little bit, we can see the true power and the apparent power. So large generator, 3-phase, 6-wire. Power factor is 0.8, just like we always say. You take the 500 divided by the 625, it would give you the 0.8. 4-pole generator, so we are turning at 1800 RPM. 480, 277. Temperature rise here. The ambient, they want us to install this in an ambient temperature not to exceed 50 degrees Celsius. And they do not want our windings inside to increase in temperature over 80 degrees over the ambient, or it would damage this class H insulation right here. So we have to pay close attention to that. Many times we will embed a thermal detector into the windings so that we can monitor that temperature rise. And that's very important. This one does have some information about the enclosure. It is IP enclosure, manufactured in 2013. The sequence is going to be T1, and then T2 and T3. So many times we would say phase A, phase B, phase C. This gives us an indication on the rotation. So this is going to be counterclockwise while facing the drive end. Important to understand that. This one is a continuous duty generator, so I can run it 24 hours a day, as much as I want, right? The XD saturation, this also gives us an idea about the fault current that the generator can produce. So very important that we understand that besides everything else. Let's take a look at the other side of this one a little bit. So again, we have the exciter. So this is where we're going to get, of course, our magnetic field to produce our sine waves. Gives us a little bit idea about the field amps and the field volts again. Then we get a warning notice on this one, which if we were going to install this in a hazardous location, then they're talking about class 1, which is gases and vapors, that there is an explosion hazard here. So we got to be very careful about that. And they do give us some information at the bottom about some different groups of vapors that we might encounter. So a lot of information on these nameplates, no question. And we should always pay really close attention to the little details on here because it's going to impact our performance if we go outside some of these parameters. Now we're going to take a look at some safety labels that might be on these generators. Very important that we have these in a good place that everybody can see. In other words, for automatic start, right? That could start without warning. That's going to be a lot of, let's say, surprises for different people that might be in that vicinity, right? I mean, our diesel engine's very loud, and when they come on, people. It could just be that we need to train the people that are going to be around that generator a little bit also. Then we have a maintenance requirement label. I usually call this the log, and what we're going to do as far as loading the generator down, changing the filters. So want to change the air filters, oil filter, any filters that are on it on a regular basis, and we want to log that. I definitely want to log the hours that the generator has run in the course of the last time that we did exercise the generator. Want to make sure that if the generator is in a room or outside, that we mark that it is an emergency generator. And extremely important down here, that if there are two sources of supply, and how we would go and complete a lockout tagout or isolation, or maybe if the transfer switch had a bypass on it. So important information on these. So definitely talking about a second power source, we're going to have that label on there. Could also have an arc flash warning label on here. It's definitely going to need a shock hazard label, because if we are above 50 volts, we do have to let people know that there is going to be a shock hazard there. And the arc flash, it could have an opportunity to have 1.2 calories or higher, and that could be enough energy to ionize the air and turn it into a conductive plasma. But I can tell you that many times on a generator, the fault current is going to be much lower than the utility would be. So we're going to have a lower fault current, but we are going to have a longer clearing time. And so that could result in some fairly high incident energy levels. Definitely want to have something on there to going to indicate to us that this is a higher voltage than 50 volts, right? And that there could be a shock hazard involved. We would definitely want to know the exact voltage on that label, and that is just a pet peeve of mine. If we're going to tell people that they're qualified, then my number one top criteria on that is they have to know the voltage. And I don't care what we're dealing with, they're going to have to know that. Extremely important here as far as the exhaust. If we're using gasoline, then we got to know about carbon monoxide. Diesel has a lot of toxic vapors there also. So we want to be careful where we're pointing that exhaust, and let everybody know that the exhaust can be quite a hazard. And then the surface, it's just going to be what it's going to be located on. That not designed to stand on specific surfaces on the generator, but there could be some information there. Also wanted to let you know about the emission label that we have to put on now. So since 2007, the EPA has required that we do meet the new emission standard, which is the tier categories. And we should be there by now. Everybody should be up to tier 4 by now, and it is going to meet all of the emission standards for especially nitrous oxide. And the manufacturers are doing that with their emission system. They've got a very complicated catalytic converter on there. They're monitoring the emissions. They are bringing it up to a very high temperature, filtering it, and meeting all the emissions requirements that the EPA has mandated for us. So those are a few little things about the nameplate on a generator and some of the safety labels. And so I am going to now allow Ryan to have some Q&A for us. So Ryan, back to you.
Thank you so much, Bob. Yeah, and I concur with him that it is an interactive session from here on out, however long we would like to go. So feel free to get into that Q&A button. And if any questions are popping up in your head about generators in particular, feel free to ask Bob the question. We'll see if we can answer some of the questions directly from the folks in the industry working on these generators. One question we got in, Bob, is a comment about, is it common for generators to be rated 240 or 480 volts as opposed to 460 volts common to motors?
That's a great question. And so what is common is that we normally would not have that zigzag switch. We would normally have one voltage output. And we have to understand this, that ANSI, the American National Standards Institute, has come up with our voltage classifications for us. And here in the United States, our classification for voltage, what the utility has to supply, and generators would be 480-277. Now, of course, we buy a motor and we look on the motor nameplate, and the motor nameplate is going to say 460 volts on it. But all motor manufacturers know this, that their motors can withstand plus or minus 10% of a voltage rating. So we could go 46 volts above this, 46 volts below this number, and that motor is just going to operate properly. So this is a nominal voltage that we have here in the US. Of course, all countries don't have that voltage. We go over to Europe, they're going to have 440. And so the motor manufacturers, which is 105 different motor manufacturers, are going to put this voltage on their motor, but that motor is going to be able to operate at 440 or 480 relatively easily. And of course, you go up into Canada, you've got 575. So the motor manufacturers are going to try to take into consideration as much of the nominal voltages that the utilities are giving us. That was a great question, Ryan.
Yeah, great question, y'all. And we're getting some other great questions coming in here on the Q&A line. So I think we saw in an earlier nameplate about CCWFDE. Does that ring a bell, Bob?
Sure, counterclockwise while facing the drive end.
Yes. Aha. So if you're looking at the drive end of the shaft kind of facing directly on that end, it's counterclockwise when you're facing that.
That's right.
That makes sense. So hopefully that helps answer that question. Good question. I didn't know what that meant either. Good question about grounding and its necessity, I guess you could say. Is it necessary for portable generators to have grounding cables when they're being used?
That's a great question. And so we have to take a look at the wiring method that we're going to be using. So on portable generators, if we run an extension cord and our load is plugged into that extension cord, right on the generator, they are required to have GFCI protection. So the receptacles that we plug into on the generator will be ground fault circuit interrupter protected. And as long as we are not hardwiring into the facility, then our generator can not have any grounding whatsoever. So everything will be taken care of through the GFCIs on the generator. Now, if we decide to go ahead and hardwire into a facility, then we are going to have to connect that generator to a grounding electrode system. And we could connect it to a ground rod. The only issue with that, 250.50 of the National Electrical Code says all grounding electrodes on any premise will be bonded together. So if we just drive a ground rod at that portable generator and we hardwire it in there, we have got to connect that ground rod to metal water pipes, building steel, the rebar, whatever is present for other grounding electrodes. So I always say that it's very nice to just run our grounding electrode conductor out to that generator. That's a much better situation. And on portable generators, what I like to see a transfer switch that we can go into that might be able to handle a twist lock connector. That way I'll have a twist lock on the generator, a twist lock connector at the transfer switch, and then there is no grounding requirements at all for my portable generator, because we've got to understand that portable generator is going to be moved every now and again. So that's the easiest way out of it, is to go with cord and plug, and then no grounding requirements at all.
Gotcha. These nameplates we've been looking at, they're just such a crucial place for all the information on how these generators operate and some of their safety specifications. Where can we usually look to find these nameplates on particularly a stationary generator? Is it right there on the side, or is it somewhere else usually?
Okay, so where you're going to go to see that nameplate would be at the engine control unit. So when we have stationary generators, of course, there's going to be two ends to the generator. There's going to be the mechanical end, and there's going to be the electrical end. Well, on the electrical end, you are going to have an engine control unit where you can perform a lot of functions there. You can actually start the generator, bring it up to temperature, check out the temperature of your lubrication. So you can take a look at the oil pressure. You can look at the oil temperature. You can take a look at the lubricant, make sure the lubricant is, the cooling. You can take a look at the cooling, make sure that is good. So that nameplate will be at that electrical end of it, where the engine control unit is. And on the new modern generators, we can program the engine, and we can put in a lot of different parameters. We can get a lot of information right there from the display. Could go right through and take a look at when we want to exercise it, when the battery status, all that would be good information prominently given to us from the manufacturer. So you're going to find that nameplate right at the engine control unit.
Excellent. We have really great questions, y'all. We got a few more coming in. We'll see how many we can get to before the hour is out. So another label, important one, is that arc flash safety label with some of the arc flash information on it. Where does that usually come from? Is it provided by the manufacturer or maybe the owner of that equipment, having to have an engineer perform an arc flash analysis and all that?
So that's a great question. And the manufacturer can provide a generic arc flash warning label. And so it can pretty much just say arc flash hazard, refer to NFPA 70E for personal protective equipment requirements. But when that generator is on site and it has been installed and it is stationary, then we are going to have to label all of our distribution equipment. So we would have to label the switch gear. We would have to label, of course, the transfer switch, main distribution panel. And so that would have to be done right at the facility. And that would be part of the arc flash analysis. Usually the arc flash analysis is going to take into consideration the worst case scenario. So the utility usually has a higher fault current. And so the label that is going to be installed, let's say at the transfer switch, would probably reflect the information coming from the utility. At the generator, many times we're going to have a generic label there, only because of the fact that the fault current is much lower. And so, but it definitely should be taken into consideration when we are collecting data and putting it in our software, because at times we could be surprised. And so we definitely want to model the whole system and take a look at what type of short circuit current or what level of short circuit current the generator is capable of, and the clearing time of the overcurrent device on the generator. But it should be done at the facility.
Awesome. So we got some curiosities from one of our attendees about the Zig Zag Switch. So the one that can switch between the different modes there. Can that be used while the generator is operational?
No. So
Okay.
the generator we would bring the generator down and make sure it's not running at all, and then we would switch that switch, only in a electrically safe work condition. By switching it when it was operating, a lot of different scenarios could happen, and we are closing different contacts when that happens, so there could be arcing involved. Also, we could have a high amount of current because of the fact we are taking some windings out of the equation and putting other windings in a different type of configuration. So that should always happen when we are at a non-running situation.
Let's see. Here's a really good question, and it probably pertains to anyone who might be listening, and that is, how often should our generator be tested?
Oh, that's excellent. That's a great question. So I want to come back to NFPA 110, which is the standard for emergency power. And so if your generator is at all part of a, let's say, emergency power situation where you might be firing up emergency lighting or at a hospital or whatever, depending on what your load is, NFPA 110 says that that generator should be tested every 30 days. Now, personally, from installing a lot of generators and maintaining them, here's what I always tell people. The more that we test the generator, the better the generator is going to run for us when we need it. And so no different than any engine, right? We want to make sure that the battery system has been charged continuously. We want to make sure that the starter is good. The more we run the generator, the more reliable the generator is going to be. So if I'm personally going to install a generator, I usually don't let it go more than 2 weeks before testing it. But we have minimum would be once every 30 days, and then once every 90 days, we want to make sure that we test that under a load. And so some people will bring in load banks, other people will transfer the whole building over, but we need it under a load so that we can make sure that we're getting the engine up to temperature also and the exhaust. And so both of those are very critical. We want to make sure that we put the engine through its paces, and then we want to make sure that the exhaust temperature or the stack temperature is up there to burn out any particulates. We do not want to have what we call wet stacking occur, which could impact the output of our generator. And so it would um, introduce some back pressure there, and we just might not get the desired output. So the more often we test it, the better we're going to be. Some smaller generators, I actually test them weekly, but definitely once every 30 days would be the maximum for me. So.
Excellent. We're getting some good questions. Unfortunately, I think I'm finding we're not going to be able to get to them all, but I'm going to try our best to summarize them for Bob, and we can talk about them. One attendee here has a question about and a curiosity about consumption on the mechanical, the fuel end. Is there a way to calculate BTU consumption, I presume, of the fuel of a generator? Or is there some sort of standard consumption for, let's say, a 150 kilowatt generator as an example?
So that's a great question, and I'm going to use diesel as an example. Most of the people here do have diesel engines, and so when we introduce that fuel into the engine, a diesel engine is going to be about 40% efficient producing electricity. So most of the waste is going to go out the exhaust, and so in the form of heat. Many times we're going to capture that heat, and we can capture that heat with heat exchangers. We can change that energy over into steam. We can help cool buildings or heat buildings with that. But if we're not doing that, if we're not part of a cogeneration system, which is capturing the heat coming off of the exhaust system, then it's only about 40% efficient. And but we use diesel. We use diesel a lot. Very reliable, very powerful, and that is our main prime mover. Is a diesel engine. Natural gas is becoming very popular, especially where I live. Natural gas is readily available for us. It's a very clean fuel. Not as much maintenance with natural gas, and a natural gas system is a little bit more efficient, but diesel, we're only getting about 40% of that energy out there to generate electricity with.
Gotcha. On the labeling requirements, since the focus of our webinar is on label, before I pose this next question, I just want to remind everyone who is here that this generator topic is rich with a lot of information on both mechanical and electrical knowledge. So highly encourage anyone here who's interested in learning a more deep dive on the knowledge of generators and some of the, for instance, frequency of maintenance and that kind of thing, creating a checklist and working through calculations of BTU, kilowatts, KVA, understanding all those things. Take one of the 2-day courses from here. I think it would be a great next step if you're continuing to have more questions.
Hey, Ryan, before you
yes.
get into that next one, I do want to mention one thing about that BTU calculation.
Yes.
There is an online calculator that people can go to, and I'm not exactly sure of the website, but that online calculator will do that calculation for them.
Yeah, maybe type into your search engine BTUs to kilowatt calculator or something like
There
that.
you go.
Probably find
Yeah.
something good.
I think
Yeah,
it's from
absolutely.
I think it's from Diesel Service is where the calculator is.
Oh, cool. Great to know. So we got the labeling requirements and wondering if they change, if those labels need to change, if the generator is in the open versus in an enclosed space, and maybe other considerations there.
No, I haven't seen any labeling requirements change because of the location of the generator. So pretty much we still have to have the same information, whether it's inside or outside. So we would have all of the nameplate data, of course, the voltage and the frequency and all of that would be there right straight from the manufacturer, of course. And we still need all those safety requirements that, let's face it, if somebody is outside and they're close to the generator for whatever reason, who knows what reason they might be close to that generator, they should know that generator could start at any minute. And they should know that there's some hazards involved there, especially a shock hazard and an arc flash hazard.
Excellent. Yeah, I think I can address this one. One of our attendees asked, but definitely weigh in. You're mentioning wet stacking there, Bob. Is this related to this individual's question? Does running with no load damage the generator? And is that wet stacking there, Bob, or is there something else you'd like
So
to add?
there it is. That is the key to wet stacking. If we exercise our generator with no load, we are not loading the diesel engine down, and so the diesel engine never reaches its rated temperature, and so that is true of the exhaust also. And so I compare that to burning wood in a wood stove. So let's say that we decide that we're going to have a wood stove and we've got some wood and we put it in and we barely open the dampers. We barely let any air in there to create a really nice hot fire. Then in the chimney, it's going to build up creosote and all this particulate wood, which would catch on fire because we're going to trap the heat in there. And so, same idea here. If we don't get that generator running under um, at least 30% load. I like to see it up near 60% load or higher. And I like to see different loads put on the generator. I like to see some capacitive reactants and some inductive reactants along with resistance and vary them at different times. And when we do that, then the diesel engine will get up to temperature. The exhaust will get up to temperature. We'll burn out all the particulates, and we will not have to worry about wet stacking at all.
Excellent. So we talked about kind of how often to run our generators and to test them. How about this other piece of equipment as part of the mix, which is our transfer switch, which connects the generator to everything that it's servicing during the event of an outage. How many times should we test that transfer switch each year, would you recommend? Or is it just testing the generator you think would be required?
Oh, no. We also, that's a great question, the transfer switch. So I can tell you first, I want to talk about maintenance on the transfer switch. So the transfer switch, of course, is the brains of the whole system, right? It's monitoring everything. It's monitoring the utility coming in. Many times our transfer switch will also have some UPS power in there. And of course, the generator also. And the transfer switch can be many different varieties. I mean, we could have an open transfer. We could have some type of closed transfer. We could have a subcycle transfer. And so these transfer switches can get very complicated. They send a signal to start the generator. They trickle charge the batteries for us. So a lot of things going on inside that transfer switch. Now, we should test that transfer switch monthly also. And a couple different ways we can test that transfer switch. We could go ahead and just there's going to be a test button on the transfer switch, and sure enough, what will happen when we press that test button is the generator will come on, but we're not going to transfer real fast. It's going to synchronize the utility power with the generator before we make that transfer. So I'm going to say when we press that, there could be sometimes up to 45 seconds before the transfer occurs. But it's just all we're doing is just testing the transfer switch, right? I mean, there's no outage, and there won't be an outage in that case. But we're not really testing everything when we do that. We're not testing the signal coming in from the utility. So at times, I'll take a time frame, maybe 3, 4 o'clock in the morning when not much is going on, right? And I'll go in and I'll actually shut down the switch gear. And so now we're really testing everything when we do that. And so I might do that once a year. I'll also do maintenance on the transfer switch once a year. And so that's kind of important. Uh, I also want to test the personnel, right? So, and I'm going to say, let's say at a hospital or a fire department. When I shut down the whole building, I want to know how the people are going to react, right? I want to know what they're going to do, what they're going to see, how they're going to feel when it's under the generator power. So there's a lot of considerations when we do that. Management gets kind of concerned when we shut off the switch gear, but how else can you test your whole system? And so I might only do that once a year, and depending on the facility, it could be during a shutdown or whatever. But other times I will test right at the transfer switch. And if I'm not going to shut down the whole facility, then I'm going to at least press that test button on the transfer switch once a month. Great question.
Yeah, thanks for these really great, just detailed questions here, everyone. We got time for maybe 2 or 3 more tops. I'm going to try to answer the best ones with folks we haven't been able to help answer yet. I will start with this one on another application for a generator for an RV, a recreational vehicle. So I our recreational vehicle generators, are they typically bonded neutral to frame? And I presume that would be a portable generator, it sounds like, in this case.
Well, and there's different types of RV generators, but normally what we're going to see in that instance is that everything would be bonded. So whoever did the wiring and installed the pedestals at the RV park is going to have everything bonded there. The pedestal is definitely not its own power source, so we're not going to need a grounding electrode there. All we're going to have to do is just bond and make sure that the frame of the generator is bonded to the windings of the generator. And then all we're going to have to do is make sure that generator is connected to the RV, and that would be it. We're not going to have to drive a ground rod. None of that would happen with an RV generator. Great question.
Excellent. Let's see. I'll throw this very applied situation to you. So we've got a number of specific questions about individuals and applications. I'll urge those folks to follow back up with us. See if you can take one of our virtual courses coming up and really get those questions answered directly with an instructor. Maybe Bob himself next week, 2 weeks. We have these virtual versions of this class happening all the time. But for this one, we can try to address right now before the end. Here's the situation, Bob. Can I ground a 1000 kW generator, so it looks like 1 MW generator, mounted, let's see, a trailer mounted generator to a high resistance diode tied to the neutral, as opposed to a solid ground? And the generator is wound Y, but only 3 phases are being used. And it's also temporary usage, I come to understand. So I know it's a very applied example, but maybe any comments or recommendations you'd have on high resistance versus solid ground for such a
Sure.
large generator?
So a lot of people on the call might not have a good understanding of that, but at times we do intentionally put in some resistance in our grounding electrode conductor to limit the fault current on a ground fault. And but in this situation, on a solidly grounded Y system, we're going to make sure that that is connected directly to our grounding electrode system, and we're going to be able to program the overcurrent device, and we can set the trip level on a ground fault. I would suggest probably at 100 milliamps in this case. So depending on where the generator is, I guess if the generator was near a marina, I might go down near 30 milliamps, a little bit there, but it is going to be a solidly grounded type of a grounding electrode system. There will be no impedance or resistance installed in that grounding electrode conductor in that case.
Excellent. Thank you so much, Bob. And one more question to just ask about your preference here, and that is, what is your preference of diesel powered versus natural gas powered generators in how they function, how they work, maintenance, any sort of aspect you'd like to share?
That's great. That's a great question also. So that's going to depend on the load, right? And so the first thing I'm going to do is I'm going to do a load profile. And if I have a very large facility, and I'm going to talk, let's say data centers, hospitals, then my preference is diesel. In that case, we're going to have more output, very reliable, but more maintenance with diesel. There's no doubt about it. Now, if my load is a little bit smaller, let's say a hotel or some type of smaller manufacturing facility, I personally prefer natural gas because less maintenance. And if I'm the one doing maintenance, natural gas is just a great way to go. I mean, whenever you change the plugs, I mean, they're all so clean. I mean, the filters are nice. I mean, the whole, when you get inside the housing that the generator is in, it's just much more cleaner environment. So the load pretty much determines that. And if I have a very large load, I'm going diesel just because of the reliability. And the output. If it's a smaller installation, I really prefer natural gas.
Excellent. I like hearing kind of the pros and cons of each. Well, everyone, I think that's about all the time we have for questions. We had to leave a few on the table, unfortunately, about how often to change our batteries, understanding how to check the antifreeze in these different percentages of load capacities, and how to best maximize some of the component life of your generators and applications in healthcare facilities, and a bunch of stuff about aerating your fuel, and just a bunch of really cool questions. Definitely, again, take a class with our expert instructors, get all those questions answered, and really get your official certificate and training under your belt as well for generators. I think it'll serve you to do more in-house inspection and maintenance of generators than relying on more expensive, maybe third parties to do the same job. So with that, thank you so much, Bob, for your wonderful expertise here, and thank you everyone for being here. Have a great day.